And we're now recording. Right, we're getting near the end. So we're up to section 13.2. I won't finish it today, but that's okay. I still have a little bit of tomorrow. And then you'll get a quiz on that tomorrow. Okay, and then remaining calendar next week, 13.3, 13.4, 13.5. Okay, then Thursday quiz, and also any questions and answers that you may want to have in preparation for the test. Okay, so our last regular test, Monday the 17th. That's our 6th exam. So coverage is 11.1 all the way to 13.5. You know all the rules. You have to submit at least 70% of the homework. Okay, and then the rest of the days, and by the way, I'm not going to guarantee you that I'm going to give you back the test the next day, but I'll try to get it back to you, that week. So at least you'll have to study it for the final exam. I'll try to prepare at least a solutions video, just like before, so you can study off the solutions video. So sometime this week, I'll get you back your test so you can see your score, but I'm not sure I'm going to get it the very next day, but you'll get it before the final. Okay, so final exam again, Monday the 24th, 11:10 to 1:40. To study for the final exam, just study the old exams. You've already got 5 of them. And we'll review on these last days, and the 6th one is to come. In terms of cheat sheet, you can bring all the previous cheat sheets with you. I hope you didn't throw them away. Figured out, well, why reinvent the wheel and make new formula sheets? Might as well just keep it. So whatever formula sheet you use for the first test, and the second test, and the third test, and the 4th test, and the 5th test, and this upcoming test, just bring them all together for the final exam, and you may use that for the final exam, okay? And that's what's gonna happen. And of course, for the final exam, there's no homework to turn in. All the other tests, including the next test, Monday the 17th, you have to turn in homework. There's no homework to turn in for the final exam. You just take it, and that's it, okay? All right, so today I'll do most of 13.2, but I won't quite finish it. I can finish it tomorrow and then go ahead and give you the quiz. So again, most likely we'll finish early. In fact, I think we're going to finish early just about every day from here on out, unless people have any questions. All right, so does anybody want to ask any questions now? Let me check the chat. I don't see anything, so I think we're good. All right, so we'll go ahead with the new material. Some of this is actually old material. So 13.2, the topic is the remainder theorem and the factor theorem. Okay. So we're going to be given a polynomial. By the way, again, anytime the text refers to a graphing calculator or something, don't do it. I'm not requiring you to have a graphing calculator. Okay. So we're doing this polynomial division stuff. Okay. And some things that I want to tell you about as we go along. Remainder theorem and factor theorem. I'll tell you about it when we get to it. Okay. Something called the multiplicity of a root. Multiplicity of a root. Root means solution. Okay. See where it says example 2, page 927. X minus 4 squared, x minus 5 cubed is equal to 0. Okay. If you were to write it all out, I can't point it to you because I'm lifting up the book, but see where it goes, x minus 4, x minus 4, x minus 5, x minus 5, x minus 5. That's really what it means, right? By setting each factor equal to 0, we have the roots. Root means solution, 4, 4, 5, 5, and 5, right? Well, I said 4 twice, and that makes sense because it says x minus 4 squared. And I said 5 3 times, and that makes sense because it's x minus 5 cubed. So the language we say is multiplicity, okay? So we say the root of 4 has multiplicity 2. The root of 5 has multiplicity 3. Okay, that's the language we use. So when you see a squared, then we're going to say that root, that 0, which is 4, is multiplicity 2. The cube means multiplicity 3. If there was x plus 1 to the 8th power, then -1 would be a root of multiplicity 8. That's all. Okay, so when you see multiplicity, that's what it means. So if you write it all out, then you would say, oh yeah, the solutions are 4, 4, 5, 5, and 5. Say, wait a minute, I said 4 twice, so that's why we say multiplicity 2. And I said 5 3 times, so that would be a multiplicity of 3. Okay, so that's just language. Do we have there? Okay, here's the remainder theorem. I'll get to it in time. I mean, you can put that in your cheat sheet if you wish. 928, I'll get to it. Okay, so you don't have to write it down now. I'm going to write it in a little bit. Okay, the first problems. So on the homework, we had 13.2, 1 to 23 odd, 27 to 37 odd, 47 to 51 all. Okay, seems like it might be a pretty big assignment. So that's why I'm not going to do it all. If I do, great, but if not, it's okay. I can still save some of the problems for tomorrow. Okay, so we had to go up to 51. So let me show you the problems. Page 933. All right, so again, this is for those of you that don't have the book and aren't getting it. Maybe you want to see the directions also. Okay, so that's up to 23-ish, I guess. And then on the next page, 27 to 37. A lot of words there. Okay, 27 to 37. The quiz tomorrow will be a problems like that, something like 27 to 37. So I have to show you for sure how that works. But if I don't, you can still do it tomorrow. Looks like it might be a longer type of problem, but hopefully not. Okay, and then what else do we have to do? 47 to 51 all. So I should at least show you the evens. Find a polynomial equation satisfying the given conditions. If no such equation is possible, state this. Okay. All right, first problems. Okay, we're doing all polynomials now. Okay, these are all polynomials. Okay, whole idea is we're going to try to factor these. Determine whether the given value for the variable is a root of the equation. Root means solution. Okay, I'm not sure about root. Solution. Put the word solution. All right, so 1, 3, and 5 should be pretty easy. Just plug it in. It either works or it doesn't work. Right? So here we go. Number 1. (12x minus 8) is equal to 112. X equals 10. Is it a root or is it not a root? Just simply plug it in. It's either going to be true or false. Just put that right in there. 12 times 10 minus 8 equals 112. 12 times 10 is 120. 120 minus 8 is 112. So yes. And you have to admit that's pretty easy, right? Okay, well, it's hard if you have a fraction, and it's even worse if you have a square root involved. So the next one I'll do is 5. A little bit harder because of the fraction. So 2x squared minus 3x plus 1 equals 0. X equals a half. Two x squared minus 3x plus 1 equals 0. X equals a half. Plug it in. 2 times 1/2 squared minus 3 times a half plus 1. Well, let's see. 1/2 squared is 1/4, right? 2 times 1/4 minus 3/2 plus 1. 2 times 1/4 is 1/2. 1/2 minus 3/2 plus 1. And that is equal to 0. So that's also a yes. Okay, now for a pretty bad one. And for the bad one, when you have radicals like that, we just use our calculator. X squared minus 2x minus 4 equals 0. X is equal to 1 minus the square root of 5. Okay, that's a big mess. X equals 1 minus radical 5. Okay, I'm gonna get the calculator out. And if you have an answer button, it's gonna be much nicer than if you don't have the answer button. Okay, so I'll address what happens if you have the answer button. Okay, because then you can just type this out directly. Okay, now if you don't have that, all you can do is just work that out. So let's punch out 1 minus square root of 5. Negative 1.236, blah, 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 blah. Okay, for those of you that don't have the answer button, you can still do the problem. It's just more work. Okay? For greatest accuracy, you should keep every single digit. So you folks should actually write down negative 1.23606797775. Okay, square that minus 2 times that same thing, and then subtract 4. Okay, it's possible, but tedious. If you have the answer button, inside the calculator or computer's memory is answer. So I can just take this operation, and everywhere I see X, I'll just put answer. That means I'm going to go answer squared minus 2 times the answer minus 4 and see what it comes out to be. And when I hit answer, second function answer, to the calculator, it's the same thing as if I typed in negative 1.23606797775. Okay, so watch what I do. Answer squared, second function answer, right? It's above there in yellow. So second function answer squared. So there's answer squared in my calculator. Minus 2 times the answer. And you don't actually have to type the times on most calculators. It knows the understood order of operations that if I just put a negative 2 answer, it knows it means multiply. So this is the same as negative 2 times the answer. And then minus the 4. Okay, see that? Answer squared, X squared, minus 2 times the answer, minus 4. It's just like I typed in negative 1.236067977 blah, 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 squared, minus 2 times negative 1.23 minus 4. Okay, for those of you that don't have the answer button, you're a little bit handicapped. You would have to actually type all the digits out for greater accuracy. Okay. And what do you know? I get 0. So this one's also a yes. So all of these are yes. Okay. All right, so that's those. By the way, you could actually get that by using a quadratic formula. So how do you come up with that weird number? You could try the quadratic formula. You see one of the roots comes out to be 1 minus radical 5. Okay, if you remember how the quadratic formula works, the other one is automatically 1 plus radical 5, and we'll get that next week, right? The solutions always come in pairs, conjugate pairs, they call them. You don't have to write that down now, I'll get it later. But if one of the solutions is 1 minus radical 5, remember the quadratic formula, the other one has to be 1 plus radical 5, right? So that pretty much does it. Now, 7 through 13 is not really any different, in my opinion. Determine whether the given value is a 0 of the function. The language is a little different, but it still means the same thing. If you plug it in, do you get 0? See, 1 through 6, it already says equals 0 for most of them. Okay, here, if it says it's a 0 of the function, it means when you plug it in, you get 0. That's all. Okay, so 7 looks too easy. I think I'll let you do that on your own. I'll do 9. H of x is equal to blah, 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 blah. X equals -1. Okay. So 9. H of x equals 5x cubed minus x squared plus 2x plus 8. X equals -1. All right, so plug in -1. If I get 0, the answer is yes. If I don't get 0, the answer is no. So h of -1. 5 times -1 cubed minus -1 squared plus 2 times -1 plus 8. Right, put -1 there, -1 there, -1 there. Okay, so does this work? -1 cubed is -1, right? -1 times 5 is -5. Minus -1 squared is 1. So -1 minus 2 plus 8. And that is indeed 0. So once again, we're getting all yeses here. Okay. Try 11. It's a little bit harder. F of t equals 1 plus 2t plus t cubed minus t to the 5th. Plug in t equals 2. 1 plus 2t minus 1 plus 2t plus t cubed minus t to the 5th. Plug in 2. 1 plus 2 times 2 plus 2 cubed minus 2 to the 5th. 1 plus 4 plus 8 minus 32. Well, you can tell right away it isn't going to be 0, right? I don't even care about the exact value. You can tell pretty much 32 is much bigger than these combined. Okay, so this one's a no. No what? No, I do not get 0 when I plug in 2. Okay. All right, then another one of these bad ones, the square root, 13a and b, 2x cubed minus 3x plus 1. A is radical 3 minus 1 over 2. B is radical 3 plus 1 over 2. So maybe I'll do one of them. The other is identical, except you do the plus. Okay. So I'll do 13a. You can do 13b on your own. Two x cubed minus 3x plus 1. X is radical 3 minus 1 divided by 2. Okay, now, if you're going to type this on your calculator, you should put parentheses here. Okay, and then I'll play the same game as I did over here when I did the answer button, right? Okay, so here we go. Parentheses, square root of 3 minus 1, close parentheses, divided by 2. Okay, so I'm typing it in like this. Parentheses, 0.366, whatever. Okay, that's going to go in as answer right here and right here. Okay, you say, I don't have the answer button. You can still do it. Unfortunately, you folks would have to go 2 times 0.366 0.254 qubit minus 3 times whatever I just said, 0.366025, blah, 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 and then add 1. Okay. For those of you with the answer key, I just type this expression, and everywhere I see X, I type answer. Okay, so I'll write out for you what I'm going to type in. 2 answer cubed minus 3 answer plus 1. Okay, and by hitting answer, it's the same thing right now as if I type 0.36602540378. Okay, so here we go. 2 times answer cubed minus 3 answer. Again, you don't have to put the actual time symbol. You could, it would still work, but the calculator or computer knows the understanding in order of operations, right? And say, oh, -3 answer, it knows its multiplication. And then what? Plus 1. Okay, so 2 answer cubed for 2x cubed minus 3x, 3 times the answer. What's the answer? 0.366, blah, blah, plus 1. Okay, this is actually 0. This means -1 times 10 to the -13 power. So if you see that in your calculator, it's essentially 0. That's -0.00045678910111213. Okay, within the limitations of the calculator, it's off by this much. So that's essentially 0. Okay, so in other words, we're going to say it's yes. Okay, there was a rounding off error, right? In reality, there's more digits. There's infinitely many digits. By stopping there, we got a little bit of an error to within 10 to the -13. Very small error. So we're going to say it's a yes. Okay. All right, now we have some of this multiplicity stuff. So list the distinct roots of each equation. If there's a repeated root, specify its multiplicity. Okay, it's not that big a deal. X minus 1, x minus 2 cubed, x minus 3 equals 0. So here are the zeros. So if I wrote this all out longhand, it'd be x minus 1, x minus 2, x minus 2, x minus 2, and then x minus 3. In which case I would say the solutions are 1, 2, 2, 2, and 3. Well, you repeated yourself when I said 2, 3 times. So x equals 1 is multiplicity 1. Okay, so multiplicity, that's a big word. If we know we're talking about multiplicity, I'm just going to put mult, M-U-L-T, for multiplicity. X equals 2. So I'll write it long way this time, but very rarely after this. Multiplicity 3. Oops, I put the extra I. That's okay. And then x equals 3. Multiplicity of 1. Okay, so from here on out, for multiplicity, the repeatedness, I'll just put, the number. So there's no repetition for x equals 1, so multiplicity 1. No repetition for x equals 3, multiplicity 1. But there's a repetition for x equals 2, exponent is 3, so the multiplicity is considered 3. Basically, you can just say, what's the exponent? Exponent is 1, multiplicity 1. Exponent is 1, multiplicity 1. Exponent is 3, multiplicity 3. Okay, so that's all. Okay, 17 has A, B, and C. They're very similar. Maybe I'm just going to do C. If I do C, you can do A and B very easily. They kind of have the same thing. X plus 1 squared, x plus 2 cubed equals 0. Right. So what number makes this 0? Negative 1. What number makes this 0? Negative 2. And they're both repeated, multiplicity. So we say x equals negative 1 of multiplicity 2. X equals negative 2, multiplicity 3. That's basically all there is to it. So you can do the others. In fact, I can probably just talk about it. For 17, A, B, and C, the solutions are all negative 1 and negative 2, right? Look at 17, A, B, and C. The solutions are x equals negative 1 and x equals negative 2, but just different multiplicities, right? So that's all. So A, negative 1 has a multiplicity of 2. Negative 2 would be a multiplicity of 1, and so on. Okay, then moving right along, 19 to 23, what do they mean? Use the remainder theorem as an example to evaluate f of x for the given value of x. Okay, so what does that mean? 19. F of x equals 4x cubed minus 6x squared plus x minus 5, x equals negative 3. Basically, they want f of negative 3. Okay, so just plug it in directly first. 4 times negative 3 cubed minus 6 times negative 3 squared plus negative 3 minus 5. Okay, so that's kind of clumsy. Negative 3 cubed is negative 27. Negative 3 squared is 9. Minus 3 minus 5. Negative 108 minus 54 minus 3 minus 5. Whatever that is, negative 170, I think. Okay, quite clumsy. So I plug it in. Negative 3 cubed is negative 27. Negative 3 squared is 9. Negative 3, negative 5. Negative 108, negative 54, negative 170. Okay, that was a lot of work. But watch this, which is a lot nicer. Let me actually divide this by this using synthetic division. That means I'm going to go 4, negative 6, 1, negative 5, and negative 3 on the outside. So I'm still in the same problem. 4, negative 6, 1, negative 5, and negative 3 here. Now you might recall from yesterday by the polynomial long division, it means I'm dividing by x plus 3. Okay, so. Right, remember if I'm dividing by x plus 3, you put a -3 here. Okay, so one more time, 4, -6, 1, -5. And the number I'm plugging in is -3. So I'm dividing by x plus 3, which means put -3 here. Okay, synthetic division. Number 4. Okay, multiply, add, multiply, add, multiply, add. -3 times 4 is 12. Add them up. -18. Multiply. -3 times -18 is 54. Add 55. Multiply. -3 times -55 is -165. -170. Okay. Take a look at -170. Got the same thing over here. This is way easier. I did not have to cube anything, square anything, or whatever. I just did the polynomial synthetic division. The remainder turns out to be the function value. Will that always happen? Yes, it'll always happen. Okay, so now we'll state that as the remainder theorem that I just showed you quickly at the beginning, but let's state it now. Page 928. When a polynomial f of x is divided by x minus r, the remainder is f of r. Okay, page 928. You can put that in your cheat sheet. I'll go ahead and write it also. When a polynomial is divided by x minus r, the remainder is f of r, which means we have two choices now for you evaluating the function. Choice number 1, plug in directly. You can see it was kind of tedious. Choice number 2, do the synthetic division. The remainder, believe it or not, will always turn out to be the function value. And that's usually a lot nicer. Okay, so I'll show you a couple more examples of how that works. (21) f of x is 6x to the 4th plus 5x cubed minus 8x squared minus 10x minus 3, x equals 1/2. 6x to the 4th, 5x cubed minus x squared. Okay. So they want f of 1/2. Okay. Well, the most direct way won't be that nice. Plug in 1/2, 1/2, 1/2, 1/2, all those fractions. You probably don't want to do that, right? Instead, do this synthetic division: 6, 5, -8, -10, -3. And just like yesterday, if anything is missing, count it as a 0. So 4, 3, 2, 1, 0, everything's there. But let's pretend it went from -8x squared just to -3, then I'd have to put a 0 here. 1/2. Okay. It still might be clumsy because of the fraction, but it's way better than raising to the 4th power and cubing and all that stuff. Okay, the remainder that I get over here will be the same answer as if I plugged in 1/2. Okay, very nice. Okay, 6 comes down. Multiply and add. 1/2 of 6, 3. Add 8. 1/2 of 8, 4. Add -4. 1/2 of -4, -2. -12. 1/2 of -12, -6, -9. So I claim f of 1/2 is -9. And you can verify that for yourself if you want to. I don't want to, but you can if you want. If you plug in 1/2 here and here and here and here and grind it out, you will get -9. But notice I never had to square anything. I never cubed anything. I never raised it to the 4th power. A lot nicer. Right? Okay, one more like that is 23. F of x is x squared plus 3x minus 4. X equals negative radical 2. That's a mean trick. Well, at least I don't have to go that far. Okay, 1, 3, -4, negative radical 2. So yeah, I don't think I'm going to like it, but at least I don't have to do that much here. Okay, 1. Multiply. Add. Well, the only way I'm going to add is just put 3 minus radical 2. Multiply. Oh boy. So 3 times that is -3 radical 2. And then that times that, negative radical 2 times negative radical 2 is plus 2. And now I add them up. -3 radical 2 minus 2. There it is. The problem's actually finished, but let me actually plug in directly. See if I get the same thing. Negative radical 2 squared plus 3 times negative radical 2 minus 4. I mean, does it even work for this weird situation when I plug in negative square root of 2? What is negative radical 2 times another negative radical 2? 2 negatives make a positive. Square root of 2 times itself is 2. Minus 3 radical 2 minus 4. 2 minus 4 is -2. So -3 radical 2 minus 2. Yes, indeed, it does match. So even in this weird situation here, it works. Okay, so when a polynomial is divided by x minus r, the remainder is f of r. All right, that takes care of that. So I've done everything up to 23. Okay, so 27 to 37, I'll hold that off until after the break. 47 to 51 all. How do I do that? Okay, to give you a degree, find a polynomial equation satisfying the given conditions. If no such equation is possible, state this. Okay. So 48. I'll do the even ones for you. degree 3, 1/2, 2/5, -3/4 are roots. Integer coefficients. So in some sense, this is going backwards from what I did over here. I'm building the polynomial. So I see 1/2, x minus 1/2. I see 2/5, x minus 2/5. I see -3/4, x plus 3/4 equals 0. Okay, that satisfies a polynomial that has solutions 1/2, 2/5, and -3/4, right? I mean, think backwards. Suppose I start off with this weird thing here, right? And I say, what are the zeros? 1/2, 2/5, -3/4. There it is, 1/2, 2/5, -3/4. The only tricky thing, though, is it says you have to have integer coefficients. So how do I make integer coefficients? I got to get rid of the fraction there and there and there. Now I see the 2 and the 4. What would get rid of both of those? Well, let's see. Multiply this one by 2, multiply that one by 4, multiply that one by 5, right? In order to get integer coefficients, which they're not. Okay, what are integers? 0, plus or minus 1, plus or minus 2, plus or minus 3. Basically no fractions. So multiply this by 2, multiply this by 5, multiply this by 4. And of course, whatever you do on the left side, you do on the right side. But of course, multiplying on the right side doesn't matter. It's still going to be 0 times 2 times 5 times 4. And they just distribute it in. So that's going to be 2x minus 1, 5x minus 2, 4x plus 3 equals 0. Okay. And for me, you don't have to multiply it out. Okay. If you look in the back of the book, they might multiply it out. You don't have to multiply it out. Just leave it like that. It is going to be third degree because if you multiply all this stuff out, you get an x cubed. Okay. That's a general principle. Okay. If you have an nth degree polynomial, you'll have n roots allowing for multiplicity. Okay. If we have a polynomial of degree n, we will have n roots. And that's if we allow for multiplicity. Okay. So once I see degree 3, I know it has to factor into something like this, right? I mean, just going backwards. If I multiplied all this mess out, there's going to be an x cubed and then some other stuff, right? Degree 3. So that's always the case. So if you have degree 5, there has to be 5 roots if we allow for multiplicity. Okay, so it's about our normal break time. So we'll break. I'll knock off the rest of 47 to 51. And then at the end, show you how to do some of these, 27, 37. And the quiz tomorrow will be stuff like that also. Okay. All right, so let's go ahead and break until our usual 12:10. Okay, folks, it's 10 after, so we'll go ahead and pick up where we were. All right, so picked up over here. We said if we have a polynomial of degree n, we will have n roots if you allow for multiplicity. Okay, now they don't have to be real, they could be complex, a plus bi. We'll see some instances of that. So if we have a third degree polynomial, there's going to be 3 roots. Okay, if we have a polynomial of degree n, we'll have n roots. All right, so I'll pick up from there, but just a quick reminder of our calendar. And now I see Mackenzie has joined us. So again, take advantage of Star and Mackenzie's help if they have some time to help you guys out, for exams, and please do so. Okay, so we have just one regular exam and then a final exam. And some of you are kind of borderline. In my opinion, you've come this far, we're less than, 3 weeks left. It'd be a shame to not pass the class. So if you're borderline C and D or something like that, some of you are doing great. You're already getting an A or a B, that's fine. If you're borderline, please take advantage of any additional help I can give you, Star can give you, and Mackenzie can give you. Again, Star and Mackenzie, if you want to, tell the class of any extra outings you want to have to study sessions and whatnot, feel free to put it in the chat, or you can send it over Canvas announcements. Okay, so we have our last regular exam on Monday the 17th. The Monday after that is the final exam, the 24th. Okay, so we're ending very, very quickly. All right. I mean, if you count the days, it's only 16 days, 17 days, something like that. Okay, so we're finished pretty soon. Right, so for today, we're not going to go that much longer because I'm just going to finish the 47 to 51 type and then show you a couple of these. And that will be the topic of the quiz tomorrow also. And I'll start off tomorrow by doing some of those in addition. Okay. Okay, 50. Degree 3, 4 is a root of multiplicity 2. -1 is a root of multiplicity 2. 50. It says degree 3, 4 is a root of multiplicity 2. -1 of multiplicity 2. Now, can you see right away that this is impossible? Right? Multiplicity 2 means there's going to be a squared, and there's another squared that's going to give me a 4th power, but it says degree 3. So not possible. If we have 3rd degree, we'll have 3 roots. You can't have 4. Okay, so if I just go ahead and build the polynomial anyway, okay, if a root or solution is 4, that means x minus 4. Multiplicity 2 means squared. And likewise, -1 is a root, means x plus 1. Multiplicity 2 is squared. But if you multiply that all out, you can have an x to the 4th and some other stuff, right? You can tell right away there's going to be an x times x times x times x. So it's going to be x to the 4th. It's going to be degree 4. You can't have degree 3. So it's not possible. Okay. '51 is kind of likewise. Okay, degree 4. 1/2 is the root of multiplicity 3. So that's already 3. Right? I've taken up 3. X squared minus 3x minus 4 is a factor of f of x. That can't happen because if you have 3 here, and if you multiply this out, that's going to bring you up to 5. Right? 1/2 is a root. So you got x minus a half, x minus a half, x minus a half. That's already x cubed, right? And if I multiply this out, you can factor or not, but you're going to multiply by x squared. There's going to be an x to the 5th. But it says degree 4. So automatically 51 is not possible also. Right? Not possible. because you have a degree 5. 5th degree. Okay, so again, you already were given 1/2 is a root of multiplicity 3. That's what it means, right? Number 51. 1/2 is a root of multiplicity 3, and then you also have x squared, blah, blah, blah. But if I multiply this all out, I'll get a degree 5, right? There's going to be an x times x times x, x cubed, multiplied by an x squared, that's already x to the 5th. But the original problem says degree 4. So it can't happen. All right. Go back and do some of the other odd ones. (47) Degree 3, the coefficient of x cubed is 1, 3 roots, 3, -4, and 5. That's going to work. Degree 3, 3 roots. They already give it to me, 3, -4, and 5. The 3 roots are 3, -4, and 5. The coefficient of x cubed is 1. It's perfect. So I just go x minus that, x minus that, x minus that, x minus 3, x minus a minus 4, x minus 5, done. And as far as I'm concerned, you don't have to multiply it out. That's kind of a waste of time in my opinion. Okay, it says degree 3. If I multiply it all out, there's going to be x cubed and some other stuff. So I know it's going to work. So we're kind of going backwards. If I start with this, right? If I have this factored polynomial, you say, what are the zeros? Well, 3, -4, and 5. We're just going backwards. Now I say the roots are 3, -4, and 5. Build the polynomial. Here it is. So you can multiply it out or not. I'd rather not. Okay, then last one of that type is 49. And then I'll show you how to do 27 to 37 after that. Okay, degree 3, -1 is a root of multiplicity 2. And then x plus 6 is a factor. That works. That's exactly 3. So degree 3. -1 is a root of multiplicity 2. And you already know x plus 6 is a factor. So it's perfect. -1 as a root means x plus 1. Multiplicity 2 means squared. And they already said this is a factor, so x plus 6. And that's it. Okay. Is it degree 3? Yes. It's going to be x squared if you multiply this all out, right? But we can say what it is, x squared plus 2x plus 1. And there's going to be another x after that. So there's going to be x cubed plus blah, 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 blah. So it works. All right, so I'm finished with everything except for 27 to 37. I'll do a couple today. I'll finish the rest tomorrow. So we are here. Not quite done, but we're getting there. Okay, so I'm done with that. I'm done with that. How about 27 to 37? And the quiz tomorrow is going to be like that. Okay, exercise 27 to 38. You are given a polynomial equation and one or more roots. Check that the given numbers really are roots, then solve each equation using the method shown in examples 5 and 6. I'll show you what that means. Okay, a polynomial of degree n has at most n, not necessarily distinct roots. Okay, so what does that mean? Number 27, third degree, there's going to be 3 roots. Same for 29, 31, 33. The cube, there's going to be 3 roots. They already give you one of them. I'll divide one of them out. I'll get a second degree, and worst comes to worst, second degree, I can always go back to the quadratic formula. Okay, a little bit harder would be 35, because it's x to the 4th, and 37, x to the 4th, but they give you 2 of the roots. So by that time, I can get it down to a squared. Okay, so I'll show you how to do a couple of them, and then tomorrow I'll do more, and then that's about it. Okay, so 27, they give you one solution is -3. X cubed minus 4x squared minus 9x plus 36 equals 0. And they already tell me one of the solutions is -3. That means if I do the polynomial long division, x plus 3 is a factor. After I factor out the x plus 3, I'll be down to x squared. Once you get x squared, quadratic formula will always work, although you still might be able to factor. So here's all you got to do. 1, -4, -9, 36, -3. I'll do the synthetic division. What number do I expect right over here? If this is a root? 0. Should be 0. Let's try it. 1. Multiply, add, multiply, add, multiply, add. So multiply, -3, add, -7. Multiply, -3 times -7, 21. Add, 12. Multiply, -3 times 12, -36. Add 0. Perfect. How do I read this? The -3 means x plus 3 is a factor. How do I read this? It used to be x cubed. It'd always be reduced by 1. So that's x squared minus 7x. So this factors into this. Once I get this, I already know how to do that. If worse comes to worse, you can't factor, do the quadratic formula. But you can see that's pretty easy, right? X plus 3, x minus 3, x minus 4. So I have completely factored this polynomial. And I can say what the zeros are, right? I'm supposed to have 3 because it's third degree. So the zeros are -3, 3, and 4. How can you always check your answer if you're not convinced yourself? Multiply this back out. You should get that. Okay, I'm willing to do it once. Okay, so for check, I'll sneak it over here. This is easy. X plus 3, x minus 3. That's x squared minus 9, right? Times x minus 4. Okay, forward that out. X cubed minus 4x squared minus 9x plus 36. Yep, perfect. X cubed minus 4x squared minus 9x plus 36. So we have completely factored this polynomial. So they give you one of the solutions, one of the roots. Use synthetic division to divide out. Okay, and then keep going, keep factoring after that if possible. As you can see, I kept going. So the polynomial completely factors into x plus 3, x minus 3, x minus 4. So the zeros are -3, +3, and +4. That's all. That wasn't too bad, right? Folks, I was just going to do one more and that's it. I'm not sure. I forgot if I did my focusing thing here. Now, let me do it real quick. This is from before the break. Because I know sometimes when I put the paper down, it's not completely focused. And over here. Okay. And well, let me just show you what I did so far, in case I forget. Right. Okay. 29. And I was going to stop there. I was going to do the rest tomorrow, and the quiz will be sort of like that. So x cubed plus x squared minus 7x plus 5 equals 0. 1 is a root. Okay. So the polynomial, I'll call it P of x for a polynomial. X cubed plus x squared minus 7x plus 5 equals 0. 1 is a root. By the way, a side note, this is pretty easy to check because it's easy to do math on the 1. 1 cubed is 1. 1 squared is 1. That's negative. So it's 1 plus 1 minus 7 plus 5. That is 0. So that one you can do by plugging in. But they want you to do the polynomial synthetic division. And that way you can see what the factors are. So 1, 1, -7, 5, 1. So this means x minus 1 is a factor. Right? From what we said. So x minus 1 is a factor. What's the other factor? Okay, 1 comes down. Multiply, add. 1 times 1 is 1. Add 2. Multiply. 1 times 2, 2. -5. -5, 0. How do I read this now? The original polynomial now has x minus 1, and then this is x squared plus 2x minus 5, which is not factorable, but I can always do the quadratic formula. Okay, so let me do the quadratic formula on this. X squared plus 2x minus 5 equals 0. Okay, so negative b plus or minus the square root of b squared. 2 squared is 4, minus 4 times a, which is 1, times c, which is -5, all over 2 times 1. This is 4 minus a minus, so 4 plus 20 is 24. -2 plus or minus radical 24, all over 2 times 1 is 2. 24 is 4 times 6. Take out the 4. And divide the 2 into each. Cancel, cancel, cancel. So -1 plus or minus radical 6. Okay. Ordinarily, I would leave it like that, but it really means -1 minus radical 6, -1 plus radical 6. Okay, so for the zeros or the solutions, we got 1, which is nice. -1 minus radical 6, -1 plus radical 6. There's supposed to be 3 solutions. It's a 3rd degree polynomial. Here are the 3 solutions. Now, how do you write as a polynomial? Well, it's very clumsy. Okay, well, if you think of what happened here, this is going to be x minus 1, right? In general, it's x minus whatever this is, x minus whatever this is. So here's how you write it. This one's okay. Here you just faithfully go x minus whatever is behind my finger. X minus parentheses -1 plus radical 6. And likewise, x minus whatever's behind my finger, -1 plus radical 6. Whoops, I just wrote the same thing. That should be a negative there, sorry. That should be a negative there. So if I clean it up a little bit and distribute, that's x plus 1 plus radical 6, x plus 1 minus radical 6. So this is the complete factorization of this polynomial. And yeah, you can see it's real clumsy. Okay, but there's supposed to be 3. You can tell if you multiply it all out, you have x cubed. And then all this other stuff. Right, so they give me 1 solution. After you divide it out, I get a quadratic. Worst comes to worst, I can always do quadratic formula. And there we go. Okay. All right, I'm done, folks. I'm going to show the focus thing. If anybody has any questions, ask now. Put it in the chat or unmute yourself. But tomorrow, I'll do some more of those, knock off the rest of the 27 to 37 type, and then give you a quiz on that material. It's our second to the last quiz. Then next week, again, we just have 3 more sections, 13.3, 13.4, 13.5. So maybe Monday, Tuesday, Wednesday. Okay. Thursday, our last quiz, and I'll take questions and answers in preparation for the test. Last regular test, Monday the 17th, and then we will review for the final exam. Okay, so I think I already showed you that. Let me do the focus job here. And then we're done. All right, so anybody want to ask any questions, please? Let me check the chat. Okay, I think I didn't. Anybody join late? If you join late, put your name in the chat so I can get you for attendance. Any other questions? Wait just a moment to see if anybody has any response. Okay, I don't see anything and I don't hear anything, so we're done for the day. All right, that's it for today, folks. So see everybody next time and have a good rest of the day. Okay, bye everybody. Victor, I got you.